Hi everyone, welcome back to our YouTube channel, Becoming a ROS Developer. So today I've got Ozan, who has completed ROS Basics in 5 days. So what we'll do is we'll first see a demonstration of his project on the real robot, and then we'll get into the details about how he did the project. And as usual, we'll get to ask him a couple of questions towards the end. Alright, so what I will now do is hand over the platform to him so he can begin his presentation. Alright, Ozan, whenever
Hello
you're
everyone.
ready.
I'm Ozan. First, let me introduce myself. I am an architectural designer originally, but I'm doing my PhD research on architecture and robotics at the same time. So with this motivation, I try to use ROS, and I'm following the construct tutorials, which really helps me. And today, I will demonstrate my project. Share my screen, which is about controlling a Turtlebot to follow the wall for a given amount of distance. So basically, my project do have three main steps. In the first step, our Turtlebot, our robot, tries to see around itself and tries to find the closest wall to it. Then it changes orientation, so it turns until it faces the closest wall. Then it approaches the closest wall in a distance of 30 centimeters. After it gets close, now it reorient itself so it can align with this wall, it can be parallel to this wall, so it can start to follow it. And in the second step, in the second part, it will follow the wall, and meanwhile, it will record its movement, it will record its odometry data to be able to record its distance and to be able to stop after it achieves the given distance goal. Given distance. Now I will quickly demonstrate. So here we see robot immediately start to turn left as soon as it's a find wall service called. After it faces, it waits a little bit because I gave some threshold times in between, so it waits like 2 seconds between each action to ensure that everything is going smoothly in real robot, because in simulation everything was super easy, but as soon as I start with the robot, then I start to have some glitches that I need to figure out. And I wanted to stay on the safe side, and I gave some how do you say, some cooldown times in between actions.
Alright.
As you see, after it finds the wall and approaches the wall, it starts to follow it. So I will explain in the code as well, but here three main behaviors that it can do. If it's too close to the wall, it tries to go other way around. And if it's too distant from the wall, it tries to approach it by again changing its angular and linear velocity. If it's in between, if it is in a distance that which is acceptable, it tries to align itself to maintain its trajectory within the bands, which I define in the code. And lastly, as soon as it approaches the corners, it changes its behavior, so it reduces its linear velocity and it increases its angular velocity to make a sharp turn until the corners pass. Then it goes back to the previous behavior I just defined and it just follows the wall.
Okay.
So meanwhile, all these are happening. Action server records the odometry data, which is the distance and the individual points, coordinates, and orientations that it goes through. And it says if this robot moves through a distance of 5.3 meters, which I approximate with the total distance of lap. It's not fully accurate, but it's approximate. Then it says, okay, I completed one lap, then I stop and I shut down everything. I just complete my action and service and my topic. So soon, yeah, it's not super precise, but it's almost stopped where it started, so something like this.
Alright.
now, if it's okay, I will dive into the code. I will briefly explain.
Yes, let's go for it.
So first, I want to demonstrate two different things at the same time. Yeah, this is great. So again, I said at the very beginning, we have three tasks in this project, right? First one is to find the wall. Second one is to follow the wall. The third one is to record odometry data
Yes.
to ensure that we can give a distance code to our robot.
All right.
So I defined these three different tasks in three different packages. Please ignore the last one. This was my trial and error.
Okay. All right.
So I will try to follow the chronological order of this service. So my follow wall is my main package, which everything happens inside. So the name can be deceiving. What every service and action I use, I call in this package. So I will start to explain from here.
Okay.
I will go from general to detail. So in general, what I do, I call my service server. My service server is meant to find the closest wall and approach to it and align to it. Then I start to record my odometry data. Then I start moving and following the wall. Why do I start to record my odometry data after I find the wall? There is no technical reasoning behind, but I was thinking that if you want to record the distance that you go, first you need to go to your start point, then you need to start. So there is no big technical reasoning behind, but that was my reasoning. Yeah.
Okay. Okay.
Then I subtract my scan topic. Why? Because during all this movement, one thing I need as input is the laser scan data to be able to understand if I'm following the wall or not.
Okay.
So that's why I subtract this, and I published my command velocity, because this is the command that I give to the robot's motors to say, okay, now turn this and turn that, so you can achieve this linear angular velocity and etc.
Yes.
At the same time, this is additional, but I use this since I gave some sort of goal to my robot, which is if you complete this distance stuff. So I put a ROS by timer in there to be able to check in every second if my action is complete or not. If it's complete, I will stop my ROS.
All right.
Now I'm diving into finding the wall service. So here, this is the code. Here I use a service server because I use service server because this is the connection server. The main reason behind this is something sequential. So before following the wall, first I need to find it and approach it, right? So these are two distinct steps that need to be complete one after another.
Okay.
That's why here I use a service instead of action.
Right. Right.
To define my first step and ensure that my following behaviors will start right after this one is complete.
Okay. Okay.
So here, first I define my global variables. These are the variables that I need during the process: my front distance, my right distance, and the minimum distance and the index of the minimum distance, which I will explain later. So here I initiate my code. I initiate my server again, just like in the previous one. One data that I need is the laser scan data, so I subscribe to it. Then again, one data that I need to publish to be able to make my robot move is the command velocity, so I publish into that. Here, I set my ROS rate, the amount of the rotation rate of my services to 5 in a second. As I realize that either I need to reduce my speed really low, or I need to increase that one, or it reacts relatively slowly, then it might hit the wall. So I just want to ensure it, and since I don't have any cost in this demonstration to increase this, just increase the slice.
It was a very nice observation for you to see that you can tune that to make it behave the way you want.
Yeah, I mean, right now I have any cost. I'm like a rich customer who can design everything here. So just an implementation.
All right.
Okay, I have two functions here. One, my laser callback, and second is callback. My laser callback this is a function that is being called every time I receive something new from my laser scanner. So let's dive into what's happening there. So again, to be able to find the closest wall and to go towards to it, first I need to know in which direction is this wall is, which comes from this minimum distance and minimum index. So first I check minimum distance between my robot and wall is this, let's say 10, 20, doesn't matter. But this distance doesn't tell everything by itself. I also need to know where is this distance. Is it like right? Is it left? Is it or behind? Normally this is optional. You don't need to know it. You can just say just rotate in one direction to find this minimum distance in front of you. I mean turn until it's distance in front of you. But it might take too long. For example, here robot is looking at this direction, right? So the closest direction is something like this. If I don't know if this closest direction on the right side of my robot, I will either need to say you need to turn always to the left side or always to the right side. And based on the situation, it might take a while for my robot to find the closest one. But what I do here, I take the index of my minimum distance. Since my index goes from 0 to 790, and this is 180, sorry, it's really difficult, right? And this is 360. So I say if the minimum distance is between 0 and 360, turn right. If it's the otherwise, turn left. So that's why I'm using this minimum index here.
All right, I see.
So this is only to receive the data and some meaning on it. Receive the laser data and only extract the ones that I need, right?
Okay.
And then going to my callback function. Here, again, there are 3 steps: orient, get closer, and align.
Right, okay.
So I use 3 different loops for each one of them. My loops always check 2 conditions. One, depending on what it tries to do. The second is if ROS is not shut down. I added this one because when I developing it, I realized that even if I cancel shut down all the process, it sometimes stuck in this while loops. So I want to add this. I don't know if it helped, but yeah, that was my approach to solve this problem. But again, I don't fully know that if it's super effective or not.
All right, all right.
So first, we call, as soon as our service call, what we do, first we try to understand if the closest wall is our at left or our at right.
Okay.
So if it's at our right, we turn over to right in this given angular velocity. Since it's a differential drive robot, it is able to rotate around itself. So that is one thing I'm trying to do. I don't give any linear velocity. I only try to rotate around myself to turn right.
I see.
But if it's at left, then I turn the other way around. Right. So I'm doing this until my front distance, I mean the distance that my front laser reads, is bigger than this minimum distance that I find earlier and the tolerance that I add this tolerance because, I mean, they're using this laser scanners, but they're not super precise. If I directly want to use this minimum distance, we might get stuck in this while loop, right? So I'm adding this tolerance since I don't need that much of precision as well.
Okay.
After I finish the orientation, I say, okay, now I'm directed to closest wall. I make my speeds both linear angle 0, 0, and I wait 2 seconds. This is just extra safety. There is no meaning behind it, but I just wait 2 seconds.
Okay, okay.
Then it is time to approach this wall. I say, until I am 30 centimeters further away from this wall, just have some linear velocity since we are already directed to it, and just move. As soon as it is closer than 30 centimeters, it just stops, and again, it makes all this velocity 0 and waits for 2 seconds.
Right, right.
Now, next approach before we follow the wall is to orient. So we need to be parallel to this wall. We need to take the wall on our right side to be able to follow. Because our main code is written as like this. So again, I'm using my algorithm to turn, and this time I say it's really similar to the first one. I say now my right distance needs to be close distance plus tolerance. Now rotate left until you have it. And at the end, we will have our robot directing in the movement direction, and our service will be finished.
Mm-hmm.
So as soon as our service is finished, we need to send some message to our main code to be able to communicate in between, right? We need some sort of message. And for this, I implemented a very, very simple custom message, custom server message.
Mm-hmm.
Basically, as we know, it needs a request and response.
Mm-hmm.
But we don't have any request in our implementation, so we only use response. We return a boolean called vault found.
Mm-hmm.
So if it finds the vault and finishes the process, this becomes true and sends it to our main code. If it's false, it's still continuing this some of these loops to make it until true.
All right.
So as soon as my process is complete, I return this to true. So my main code understands, now it's true. So now I know that I am next to the vault, so I can start to follow it.
Mm-hmm. Okay.
So this part, I'm closing this. I'm coming back to here. So we finished this, right? This is a tick. Now, before I start my movement, I want to record my odometry data.
All right.
So for this, I use action server because this is something not sequential, but this is something that needs to run in parallel to the other things that I'm doing.
Okay.
So
okay.
action servers are great for this, so that's why I use action server.
Okay. You got
Here,
4 minutes.
what kind of? I got 4 minutes.
Yeah.
Okay. I'm a bit faster. Here, what I need is instead of laser here, I need odometry data. So I need some data from my motors to be able to understand how much we make progress on the floor, how much we moved, right?
Okay.
So for this one, we take odometry data. So we take X and Y positions in some kind of period.
Mm-hmm.
So we are taking this X and Y, and we are comparing this or subtracting this from the previous X and Y.
Okay.
So we can do Pythagorean theorem and calculate the distance really like in triangles really briefly.
Okay. Okay.
Here I have this if statement. I say if previous position is not none, because when we call this function for the first time, we do not have any previous position.
Okay.
So first, to be able to eliminate this exception error, we first check if the previous position is there. So if it's the second time that I'm running this function,
Right.
I
Okay.
check the distance. I'm adding this to the distance. Meanwhile, I am also recording all these locations in a list that I return at the very end.
Mm-hmm.
So now I'm out. Now we approach the wall, we start to record our odometry data. Now it's about moving, right? So we are going to callback function where everything happens. So here, I will go fast. We have 3 zones. So this is the first, really close to the wall.
Mm-hmm.
The second is a good place. This is the third, really further away from the wall.
All right.
So what I do here is I use if-else, I use if-else statements. And we have also corners and we have walls.
Okay.
So I say, if you approach the corner, so if your front distance is less than 50 centimeters, take a sharp turn. So decrease your linear velocity and increase your angular velocity.
Oh, okay.
But if you are following the wall, if you are along the wall, then do this. And here we have space. So if you are really close to a wall, if you are here, make a relatively less sharp turn to get away from it.
Okay.
And if you are really further away, do the other way around to stay in the track.
Okay.
But if you are in between, I added something here. I will try to explain it really fast. So I did linear interpolation here to calculate my angular and linear velocity because the more straight I am,
Mm-hmm.
I increase my linear velocity and decrease my angular velocity because I don't want to turn, but I just want to go forward.
Mm-hmm.
But the more not straight I am decreasing my velocity,
Mm-hmm.
increasing my angular velocity, decreasing my linear, but increasing my angular velocity to get back on track.
Right. Right. I see. Okay. That was pretty nice.
So after all this, what I do really briefly, I know I'm almost out of time. So I check the completion action based on the message I receive from action server,
Mm-hmm.
and if it's completed, I start everything.
All right. It was very, very nice presentation. I like the fact that you used linear interpolation because I thought you had some type of controller in there, but clearly the way you did it is very well done. It's close to, I think, it makes me feel like you used a a PID controller at the beginning, but now I see it was just very good use of linear interpolation. So that's well done. Well done.
Yeah, thank you. I thought the PID was maybe overkill in here.
Yeah, yeah,
So,
yeah. I mean,
yeah,
given the
because
job that
I'm also architect. I'm architect. I don't know. I'm not an engineer. I don't know that much detail. I know the concepts. I know the terms. But to me, tune a PID is like it's another project.
it's it's another project. So it was quite good to get the same performance out of much simpler implementations, right? That's the whole point.
Thank you.
So just a couple of questions.
Yep.
I wanna okay. Let me begin at the service, right? You spoke about using a service because you have things that happen one after the other. So there is a particular characteristic about services that makes them ensure that you have one thing okay exactly after the other, right? And can you, if you get my question, can you at least explain to me what that is? What do they do to the system to ensure that one thing occurs immediately after?
So, okay, I will try to correct terminology, but it might be wrong. The thing is about the services, they block the thread. So if you call a service, you cannot do anything else. It blocks all the process.
Right.
Therefore,
Wonderful.
you need to wait until it finishes.
Right.
But that is the aspect that can be problematic in some implementations we use it wrong. But in this case, it is a guarantee that this will finish before the next thing starts, which is a good implementation for us.
Wonderful. I liked your answer. Underline block, right? That's what I wanted to get. Yeah. So that's a very, you answered well. The other one that I wanted to ask you is can you tell me what is the difference between an action client and an action server? Because you've got those things happening whenever you have some type of action as a communication channel, right? What is the difference between the client and the server there?
Well, this will be probably less accurate, but the server, I think it's the same case. Sorry, you said action service versus action client.
Yes, action server and action client, yes.
Action server versus action client, yes.
Yeah.
So the server is the part of the implementation, the software or algorithm that gives what you need. So that is something that you define. That is literally the server that you go there when you need something and ask it from that based on what it can provide.
Right.
And client is the thing that needs that kind of I don't want to say service, but the service is the correct term. But service is not. Action. Let's say that action. Yeah. The client is the thing that in demand of that action, so it goes there and takes it whenever it needs.
Right.
I think it's the same logic in the service server and service client as well. I'm asking right now. I'm not sure, but I think it's the same logic, right?
It is actually. It is. It's the same logic with the service communication channel. It's just that with the service, then your client is waiting to say, I will block everything else that can happen, right, until I get my response, right? Whereas with an action, you're like, well, you can do other things, but whenever you get, say, a result, give it to me. Or you can say, if it fails, just tell me that it has failed. So you can do preemption even if the task does not, or the server does not complete the task. The client can tell the server to say, oh, stop, don't do it anymore, I don't need it, right? That's the main difference between the service and the action. But yeah, you answered well there. The last bit is topics, right? Service. We've been speaking about services and actions, right? But with respect to topics, right? Let's just compare services and topics. Can you give me some ideas? What do you understand are the differences between topics and services? Dwell on the topics especially.
I mean, I always focus on the difference between service and action, but okay, the topic and service.
Yeah.
Brief think on it. Based on the experience I had, I don't know if it's the very correct
Mm-hmm.
way to differentiate, but the service is something for shorter term in the applications that I see, but
Mm-hmm.
the topic is something to run longer term, which also can run in parallel.
Okay.
So
All right.
instead
All
of
right.
looking,
I see.
but
I see.
yeah, I'm not 100% sure in there yet.
Yeah, all right. Yeah. Yeah. I do get what you're trying to say. Um,
Mhm.
it's just that with topics, right? It's a constant broadcast, right? No one is saying give me something. It's like you're just making the data available there, right? So
Yeah,
whoever the
that's the main
subs
difference.
yeah,
Yes.
whoever the subscriber or the publisher is, they don't care whether the other node or the other whatever client or server has received it. They just make it available, right? So um,
Yeah, it is always there. So sometimes some people call it inefficient because it always shares even not what it needs.
yeah, yeah.
Sometimes it's mainly needed. Yes. Okay.
Yeah, I mean, yeah, that's why you get cases where, like, if you don't want to have your channel, let's just say your general communication channels being flooded with data, you just publish with the service at once that one time, and if everyone says I've received, then you don't need to, right? It's just a once-off thing, right? So yeah, but I'm glad you got that. So I think very well done. It's a very nice presentation. So what we'll do is let's wrap it up here, and we'll continue our meeting on Zoom. All right.
Okay. Thank you very much
All right.
for the hosting.
Sure. All right, everyone. This was Ozan's presentation. Very warm congratulations to him. It was nice, clear. Got into very good details about how he went about it. So, congratulations to him. So, to all those who would like to try the courses we offer certification on, we highly encourage you to do so, and then you can come and give your presentation as well. And until next time, keep pushing your ROS learning. Bye bye.